All right, class. Welcome to this video. We're going to go over the homework problems for 1.1 in this video. So for 1.1, the first question, now notice that these questions that I'm going over on Saavas, they are actually, they're not going to be the exact same questions as far as like numbers. So questions that have maybe like numbers in them, Saavas automatically generates different numbers. So that way you can get different practice problems, per student or whatever, so that you can, so each student can practice different problems. Or if you resubmit the assignment, then you could do different problems for extra practice. All right, so the type of problem will be the same, but the numbers will be different. So just keep that in mind. So this one is a concept question, so it should be the same for everybody. Benito wrote the equations shown about the figure to the right. Explain Benito's errors. So he went ahead and said, okay, well, I know that, let me go ahead and write on this. So I know that AB, let's see here. So I know AB is equal to BC. And that's because, well, you have the single tick mark there. So they have to be equal, right? And he said the same thing for AD, DC, and so on. So yes, the line segments are congruent, right? But remember that when you're talking about a line segment, say AB, and you're saying that it's the same thing as BC, well, those are two objects. And so you can't equate two objects. You can only say that one object is congruent to another. You can't say that they're equal, right? So these two objects right here, these two line segments are congruent, but they're not equal, right? So they're congruent. And the way you would make it into an equal sign is if you eliminate the bars, right? So we eliminate the bars from the top. Well, now they're no longer objects. So AB on the bottom just stands for the length of the line segment AB, and BC without the bar stands for the length of the line segment BC. Okay, so one important thing to distinguish there. All right, so in this case, Benito had the right idea, but he used the wrong symbol, right? So Benito needed to actually use the congruency symbol. All right, so we'll go ahead and check that. All right, so it says point Y is in the interior of angle XWZ. Given that WX and WZ are opposite rays, and the measure of angle XWY is equal to 4 times the measure of the angle of W or YWZ, what is the measure of angle YWZ? So it helps to draw a picture in this case because there's no diagram to focus on. So first off, it says that we have opposite rays here. So, remember that opposite rays are two rays that are in opposite directions from each other, right? So in this case, let's say that's a ray. Now, okay, and then this other one is another ray. Okay, so those would be opposite rays. Now, obviously, they share a point, right? And that point is W because one of them is WX and then the other one's WZ. All right, so those are my two opposite rays there, WX and WZ. And it says point Y is in the interior of some angle, right? And that angle is XWZ. So we have XW Z, they're talking about this angle right here, right? So even though these are opposite rays, you can also consider this as an angle, right? And so point Y is somewhere in this angle. So let's just label point Y somewhere on this inside. And there it is. Okay, so there's point Y. We don't know where it is. We just know that it's there somewhere. So now it says, so now we can go ahead and draw a ray from W to Y. And so now we got two angles here. We have the angle ZWY and the angle XWY. So In this case, they're asking for xw. They're saying that xwy is 4 times as large as ywz. So let's call this angle here, let's call it x. So this angle here, let's call that x. Or actually, um, let's call this one x on the left side. So we're going to call ywz x, okay? So if ywz were like 5 degrees, for example, then xwy would have to be 4 times 5, right? So it's whatever the angle is, you multiply by 4. That's what that's saying. If the angle were 10, then 4 times 10 would be 40. Okay, so if the left side is x, then the right side has to be 4x, okay? And so that's what I'm going to use. I'm going to use those as the variable as an unknown, and then write an equation from that. Okay, so hopefully that makes sense from the information they give us. Now, what is the measure of an opposite of these two rays? So if you take a protractor, right, and you measure this this angle right here, this angle for the opposite rays, well, that entire angle is actually worth 180 degrees. Okay, so if you were to put this at the vertex of a protractor and then measure out the two legs, right? Well, then you're going to get 180 degrees. Okay, so that means that we can use the angle addition postulate here. So let's see, we're going to use the angle addition postulate. Remember, the angle addition postulate says that if we add these two mini angles, we'll get the big angle, which is 180. So we have x, which is the small angle, plus the other small angle is equal to the big angle. Okay, and we'll also write down the angle addition postulate in terms of the symbols. So I'll write it down here. So if we were to write it, we would say the measure of, let's see here, ywz plus the measure of, so ywz is my first one, and then my other one is ywx, or we'll call it xwy. It doesn't really matter, but we'll call it xwy, is equal to, and that's equal to the entire angle, which is zwx. Okay, so the measure of zwx. Okay, so that's like the angle addition postulate, and then and then we know that this is x, right? And this is 4x, and then the whole thing is 180. All right, so you need to practice writing the angle addition postulate in terms of the symbols, so that's why I did that there. So in any case, you're going to get x plus 4x is 5x. Okay, so if you remember, there's an invisible 1 there. And then 5x is equal to 180. So using a little algebra, you just divide by 5. And you're going to get x is, if you did this here, well, let's see, this is probably going to be a 4 here. Here, let's actually do this out. 5 goes into 18 3 times. And then 5 goes into 36 times. So it's going to be 36 here. Okay, so this should actually be a 6. So let's cross that out. X should be 36. Okay, so x is 36, but what is x? Well, we said that x is this angle here, and which is wyz, right? So basically we know what wyz is. This is the same thing as wyz. So the measure of angle ywz, I mean, I said wyz earlier. Ywz is equal to 36 degrees, and we're done there because x happens to be the same thing as that angle. Okay, so then we could just type that in to the answer, and that would be it. Now, if they're asking for ywx, then you would have to plug in 36 into 4x, right? You would have to do 4 times 36, and then that would give you that angle. All right, so just in case they ask you that question. All right, so let's move on to the next problem. Let's see here. Okay, so in the diagram, you have, so basically you have a diagram and we're measuring the stuff in that diagram. So so the measure of LMN is 116. So we'll go ahead and do that here. So LMN. So here, let's make this a little bit bigger. There you go. This is better. Okay, so now, this entire angle, LMN, is 116, and JKM is 122. So JKM, right? So that means it has to be this whole angle is 122. JNM is 103, so JNM is 103 degrees. So then what is the measure of NKM? Okay, so we're looking for NKM, and so basically we're looking for, and I'll use a different color for this. We're looking for this little angle right here, NKM, okay? So using that information, we'll need to find that angle. All right, so basically, if we look at this first clue, we know that these two angles are congruent. We know that this orange angle and then this other one are congruent, that they're the same, all right? Let me go ahead and erase that real quick. Okay, so for some reason, I don't know why, it ended up erasing the numbers. So let's go. So I'm just going to quickly rewrite it. So we said LMN is 116. So let's use that clue first. So we know that that's 116. And according to the symbols here, we know that they're identical. They're congruent. So that means that if we split 116 into two pieces, two equal pieces, that's going to give us both of those pieces, right? So basically, we could say that, okay, well, these two angles are the same, and so they had to add up to 116. And so we just take 116, and then we just divide it by 2, and then that'll cut it into two pieces, right? So 116 divided by 2 is 58 degrees. So both of these angles have to be 58 degrees. And then 58 plus 58 is 116. So now we know that this is 58 degrees, and that's 58 degrees. All right. Based on that logic, well, now we know that each of the single marks, each of these single angle marks is worth 58. So that means that this is worth 58 degrees, right? So now we know what that is. Okay, and then now we're going to use the other clue that they told us. They said that JNM is 103. So they said that this whole thing is 103 degrees. Well, that's an angle addition postulate, right? So we know J N K. So let's write that angle addition postulate. We know J N K. J N K. That's the 58 degrees that we got here, right? We know that. And we don't know what the double angle mark is here, which is KNM. So we don't know what that is, so I'm just going to call it KNM, measure of angle KNM, or you can use a variable X or something like that. It doesn't really matter. We don't know what that is yet, but then those two angles have to add up to the big angle, which is 103 degrees, okay? And that's the angle addition postulate. So this has to add up to measure angle JNM. Okay, so now we have the angle addition. This is the angle addition postulate. So now we can go ahead, okay, well, we just have to subtract 58, right, basically, and that will give us the other angle. So 103 minus 58 is going to give us that angle. Okay, so the measure of angle KNM is, let's see, subtract that, you should get 45 degrees. Okay, so now we know that this little angle here is 45 degrees. All right, and so that means that this little angle here is also 45 degrees. Okay. And so then we're going to use our final clue here. Our final clue is, well, they tell us that JKM is 122. So they said that that big angle is 122. Well then, yeah, that's a 2 right there. So then the two mini angles, the 45 degrees, and then the one that we're looking for, should add up to the big angle, 122, right? So that's another angle addition postulate. So we're going to use another angle addition postulate. And so we'll say that JKN, the 45 degree angle that we wrote down earlier, and what we're looking for, which is NKM, measure of angle NKM, is equal to the big angle, which is the 122, which is JKM. I should have written this over here. Yeah, I'll grab my eraser real quick. Okay. Which is equal to the measure of angle JKM. Okay. All right. So then we don't know what NKM is, so I'm going to just write it as angle NKM, and that's equal to the big angle, which is 122. And so basically we just got to do 122 minus 45 to solve for the equation. Okay, so 122 minus 45, that's going to give you 77 degrees, something like that. All right, and that 77 degrees is the measure of NKM, which is exactly what they're looking for in the problem. Okay, so it's going to be 77 degrees in this particular example. All right, so let's go over another problem. So this one's pretty straightforward. You used a ruler postulate. So clearly the coordinate of A is -9. The coordinate of B is 2. And so we should be able to find the length of this easily. You can count the number of spaces, or you can just do the absolute value and subtract. So the absolute value of the coordinate of A minus the coordinate of B. And then that's going to give you absolute value of -11, which is just 11. Okay, pretty straightforward. All right, and then now, so you want to use the number line, and they say RS, so let's label that. RS is this guy, 4y plus 2. ST is 3y plus 8. And then RT, which is the entire thing, is 38. Okay, so remember the bus stop example. From the home to the bus stop, from the bus stop to the school, should add up from the home to the school. So if we were to write the SAP statement, the segment addition postulate, well, that's going to be RS, and then from S to T is equal to from R to T. And then we'll go ahead and plug in what we know. So we know from the R to the S is 4y plus 2. And then we know from the S to the T is 3y plus 8. And so I went ahead and just plugged that in. And from R to the T is 38. And so now we can just solve this. It's just an algebra equation. So we have 4y plus 3y is 7y. 2 plus 8 is 10. And then we're going to subtract 10 on both sides. Sorry for the writing here. It's kind of laggy on the computer. And then we get 7y equals 28. Divide by 7 on both sides. And you get y equals 4. All right, so they're asking for what the value of y is. So we can just plug that in. Let's do that right now. And then we're going to find rs and st, but that's easy. All you got to do is plug in y and the value of y into those two. Okay, so just do the math and get that done. You just do 4 times 4 plus 2, and then 3 times 4 plus 8. I'm not gonna do that. It's just pretty straightforward. Just plug it in and do the arithmetic. All right. Okay, so we got another figure with a bunch of things on it. Let's go ahead and zoom in on the image again. Okay, so all right, so here they're looking for AD. All right, so we're gonna need if we're looking for AD, which it says in the problem, we're looking for AD. Then here, let me move this out of the way. If we're looking for AD, then that means we need anything that involves distances, okay? So I'm gonna automatically ignore angles because I don't really need angles to find the distance of that line segment, if that makes sense. We can just ignore that. That's extra information. So anything involving angles, I'm just gonna toss out automatically. They're really just extra. So we got EG is 5. So G, where's G on here? So G, let me zoom out one more. There you go. Okay, so EG is 5 and EB is 14. Okay, and AF, which is that line segment, that entire line segment, is 12. Okay, so so now we know what EG is, and so we know that anything with one single tick mark is has a distance of 5. Okay, so I know that EF has a distance of 5 as well, right? And I know that DF right here has a distance of 5. So I'm going to label that 5 just for that mini line segment. And then for the other clue, well, it says EB is 14. So anything with a double tick mark is 14 as a distance. So that means that this one right here has to be 14. All right. And that's it. That's basically it for the clues. So now it's aside from the fact that AF is 12. Okay, so now we're looking for, in this example, we're looking for a AD, right? So we're looking for this one. All right, well, this is the angle addition postulate, or the segment addition postulate, the SAP. Because we know that the entire distance from home to school is 12 miles or whatever. And we're looking for the distance from home to the bus stop. And from the distance from the bus stop to school is 5, right? So this is another segment addition postulate. So we have AD plus, and then DF has to equal AF, the entire thing. And the entire thing is 12, because that's what it says in the problem, in the diagram. And then DF is 5, okay? And then you're looking for AD, right? So we'll just call it AD, and then just solve. So that means that so if we subtract 5, AD has to equal 7, okay? And so that's my answer for that particular problem. So this next problem has the same diagram, so I'm going to zoom in just like I did before. But this time you're trying to find an angle. And so we're going to be interested in the clues that have angles in them. So we're not concerned with the line segments here, right? So let's get rid of the line segment distances. We're only concerned with angles. So it says the measure of EBG is 19. EBG is 19. EGF is 32. GF is 32, so this right here is 32 degrees. CAE is 53, CAE. So that means that this entire angle is 53 degrees. And then, yeah, I'm just going to say that this angle right there is that. Okay. And I think we got everything. So now we know that anything with a double mark, right? A double mark for the angle is worth 19 degrees. That's a 19. So that means that this angle, this little angle right here, which has the double ticks, is 19 degrees. All right. And then EGF, so anything with a single mark is going to be worth 32. So that means this angle right here, this little one, is also 32. Okay, so that's it for using the clues, aside from the fact that CAE is 53. So again, this is an angle addition postulate. So let's go ahead and use a different color here. We're looking for CAF, right? So we're looking for this little angle right there in blue. All right, so if we use the angle addition postulate, well, we know that those two little angles, this little blue one and then this little angle of 19 degrees, well, they should add up to 53 degrees, right? They should add up to that entire thing. So we're going to say the measure of angle C, scratch that real quick. All right, so the measure, of angle CAF plus, and then I'll use a different color. The blue is what we're looking for. And then this little angle, which was 19, which was equal to the big angle, which was 53. And so we subtract 19, and that'll give us the little angle. Solve that equation. So then this guy is equal to 53 minus 19, which is about 34 degrees. Okay, and that's how you would solve that particular problem. Again, you might have different numbers, but the logic is the same. All right. Okay, so we got P, Q, R, and S are collinear. What does collinear mean? Collinear means they're in the same line. So we know that we have, we have 4 points and they're on the same line, or they're on the same line segment, regardless, right? We'll just say that they're in the same line segment for all intents and purposes here. So let's just say we have one line segment with those 4 points in it. Now it says point Q is between P and R, and then R is between Q and S. Okay, so point Q is between P and R, and then R is between Q and S. So there you go. So there's our basic diagram. And it says that PQ is congruent to RS. So that means that these two have to be equal. All right, so I'm going to use that little tick mark to show that they're equal. The measures are equal. Now, if PS is 16 or 17, so that means that this entire thing is 17. And then PR is 14. This little chunk here is 14. And then what is the value of QR? Okay, well, if we know that PR is 14, well, then we know what RS is, right? Because RS is the other little chunk that adds up to 17, right? The entire thing. So 14 plus what is going to give you 17? Well, that's going to be 3, and that's the segment addition postulate, right? It's 14 miles or whatever to get from home to the, let's say, bus stop or whatever, and then from the bus stop to the school is going to be 3. So just as an example, right? So 14 and 3 is 17. So now we know RS, but since we know RS, that means we also know PQ, right? So because they both have the tick mark, they're congruent, and so we know that this is also 3. This little part is worth 3, just like this little part was worth 3. And so if we just focus on this part right here, that line segment, well, we know that entire thing is worth 14, right? Worth 14. And we know the little chunk there is 3. And so we can find this other little chunk here, which is going to be 11, okay? And so 3 plus 11 is 14. And so therefore, QR is equal to 11. All right, and you can show that by writing the segment addition postulate. I definitely recommend writing it out, like PQ plus QR equals PR. Just as practice, because you're going to need to know how to do that eventually and get used to it. All right. And then the final problem here, as we're wrapping this up. So it says point C is in the interior of ABD. So you have some kind of generic angle. We don't know what that angle is. Some kind of generic angle. A, B, and D. Okay. And it says that point C is in the interior of the angle. Interior means inside. So it's somewhere inside the angle. So let's just say point C is here, somewhere in the inside. And then it said, okay, so then that means we have to form an angle from that. Okay, so then it's saying that the measure, or it's saying that angle ABC, so ABC, so this angle right here, is congruent to CBD, right? So if the angles are congruent, that means the measures have to be congruent, right? So that means that the measure of ABC equals the measure of angle CBD, which is why I'm going to, just write that little mark there. So there you go. Those two angles are the same. And then, so we know that this angle right here, it says ABC is 5 halves. Oops. So that angle right there is 5 halves x plus 18. And then this other angle is 4x. Okay. And so they're asking, what is the measure of ABD, which is the entire thing? Okay. So we know that because these two angles are the same, we can set them equal to each other, right? So we know that ABC is that 5 halves x plus 18. And then we know that the CBD is 4x. So we can set them equal to each other. So I'm going to go ahead and erase all of this here. Okay. And so we'll set them equal to each other. So we know that the 5 halves x plus 18 has to be equal to the 4x, those two little mini angles. And so we got to solve that, of course. And so what I would suggest is get rid of the denominator by multiplying both sides by 2. Okay, so we're going to multiply by 2 just to get rid of that denominator. But we got to multiply everything by 2 on both sides, okay? So if you multiply a fraction by its denominator, well then it cancels out, okay? The twos end up canceling out. So then you're just left with 5. So we got 5x. Okay, another way of thinking about this is when you multiply a number with a fraction, that's the same thing as 2 over 1. And then we know that 2 times 5 is 10, right? So we got 10. When you multiply fractions, you multiply straight across. 2 times 5 is 10. 1 times 2 is 2. And then we know that 10 divided by 2 is 5. So I'm just going to change that to a 5. All right, so that'll be 5x. And then we got to do 2 times 18. We still got to multiply the 18 by it, which is 36. That's the distributive property. And then we got 4 times 2 is 8, so we got 8x. To solve this, subtract 5x on both sides here. And then we're left with 36 equals 3x. And then we can divide by 3. And so 36 divided by 3 is 12, which is that first answer right there. But remember, they're asking for ABD. They're not asking for x, right? So what is ABD? Well, ABD is the entire angle, right? We drew it here. ABD is the entire angle, so that means we have to add both of these mini angles to get that big angle, okay? So now we know x is 12. We said that this was 4x. So this right here is 4 times x, which is 12, which is 48 degrees. So that means that this bottom angle that I drew earlier, hopefully you drew it on paper or something, is 48 degrees because that was 4x. And so that's that if you just plug it into here. And then we got to plug in this into here as well. And then we get those two numbers and we add them together. So let's get those two numbers, add those together. So let's plug it into here. X is 12. And then, oops. Okay, so this is going to be 18. And then so to multiply this, remember 12 over 1. And then 5 times, multiply straight across. 5 times 12 is 60. And then 2 times 1 is 2. 60 divided by 2 is 30. 30 plus 18 is 48. Okay? So that means they're both 48. If you plug in here, you're going to get 48. Plug in here, you're going to get 48. And then you add those two together, and that gives you the big angle, which is going to be, what, 96 degrees? So that's the answer is B in that case. So just be careful to answer the question that they ask. All right, guys, that is it for the homework problems. Feel free to ask me any questions during class or anything like that. But and for until now, I'll see you guys in the next one.